Hi everyone, and welcome. Tonight, we'll explore a quiet and fascinating mystery: why the universe may make it impossible for any two civilizations to ever meet. So get comfortable, relax, and let your mind drift into the vast silence of space. The vast silence between stars. The idea that intelligent civilizations might exist elsewhere in the universe has fascinated humanity for generations. With hundreds of billions of galaxies, each containing billions of stars, it seems almost inevitable that life has arisen many times. Yet, despite this immense cosmic abundance, there is a striking and unsettling reality. The universe itself appears to make it extraordinarily difficult, perhaps even impossible, for any two civilizations to ever meet. At first glance, space may appear filled with stars and galaxies, but in truth, it is overwhelmingly empty. The distances between stars are so vast that even light, the fastest thing in the universe, takes years to travel from one star to another. Our closest stellar neighbor, Proxima Centauri, lies over 4 light-years away. This means that even a message sent at the speed of light would take more than 4 years just to arrive, and another 4 years for a reply. Now imagine civilizations separated not by a few stars, but by thousands or millions of light-years. Communication becomes not just slow, but effectively meaningless. A signal sent today might reach its destination long after the originating civilization has changed, evolved, or even disappeared entirely. Time itself stretches communication into something fragile and uncertain. Beyond distance, there is also the issue of timing. Civilizations may not arise simultaneously. One might emerge, flourish, and vanish millions of years before another even begins to exist. In cosmic terms, intelligent life may be like brief flashes of light, rare, short-lived, and unlikely to overlap. Even if two civilizations exist in the same galaxy, their timelines may never align. Another quiet barrier lies in the limits of physics. According to our current understanding, nothing can travel faster than light. This universal speed limit places a hard boundary on exploration and contact. Interstellar travel, even with advanced technology, would require enormous amounts of energy and time. A journey to another star system could take thousands or tens of thousands of years using conventional methods. For any civilization, such voyages would demand patience on a scale that challenges imagination. Even if a civilization were capable of sending probes or signals across the stars, those messages would weaken as they travel. Signals spread out, becoming faint and difficult to detect against the background noise of the universe. By the time they reach distant regions, they may be indistinguishable from natural cosmic radiation. There is also the quiet influence of cosmic expansion. The universe itself is stretching, causing distant galaxies to move away from each other. Over vast periods of time, this expansion ensures that some regions of space will become forever unreachable, no matter how advanced a civilization becomes. The universe is not just large, it is growing larger, increasing the isolation between its inhabitants. Taken together, these factors, distance, time, physical limits, and cosmic expansion, form a powerful barrier. They do not forbid contact outright, but they make it incredibly unlikely. The universe, in its calm and silent way, seems to separate civilizations into isolated islands, each surrounded by an ocean of space too vast to cross. And so, as we look up at the night sky, filled with countless stars, we are left with the quiet and profound question: even if others are out there, will we ever truly meet them? Or are we destined to remain alone, separated not by emptiness, but by the very structure of the universe itself? Time. The invisible barrier between civilizations. While distance creates the most obvious separation between civilizations, time may be an even more powerful and subtle barrier. In the universe, space and time are deeply connected, and together they form a quiet filter that determines whether two civilizations can ever become aware of one another. To understand this, we must first consider the age of the universe. It is approximately 13.8 billion years old, a timescale so vast that human history occupies only a tiny fraction of it. Even the entire existence of our species spans only a few 100,000 years, and modern technological civilization has existed for barely more than a century. In cosmic terms, this is less than a brief moment. Now imagine another intelligent civilization emerging somewhere in the galaxy. It may have appeared millions of years before us, reached its peak, and disappeared long before Earth even formed complex life. Alternatively, such a civilization might arise millions of years in the future, long after humanity is gone. The universe does not coordinate these events. It allows life to appear whenever conditions permit, without regard for overlap. This leads to a profound realization. Civilizations are not only separated by distance, but also by time windows. Each civilization exists within a limited period, its active phase, during which it might be capable of sending or receiving signals. If these time windows do not overlap, then contact becomes impossible, even if both civilizations exist in the same galaxy. Even if two civilizations do overlap in time, their technological stages may differ dramatically. One might still be developing basic communication tools, while the other has already moved beyond detectable technologies. Signals may be sent in forms the other cannot recognize or understand. What appears as silence may simply be a mismatch in technological language. There is also the question of longevity. Civilizations may not last long enough to bridge cosmic distances. Natural disasters, environmental changes, or self-inflicted challenges could limit their lifespan. A civilization might send signals into space for only a few hundred or thousand years, a very short period compared to the time it takes for those signals to travel between stars. Consider a signal sent from a distant star system 10,000 light-years away. By the time it reaches us, 10,000 years have passed. The civilization that sent it may no longer exist. Even if we respond immediately, another 10,000 years will pass before our reply arrives. Communication becomes not a conversation, but a slow exchange across deep time, where cause and effect are separated by millennia. Time also erodes evidence. Signals weaken, structures decay, and traces of civilizations can vanish. The universe is constantly in motion, reshaping itself through gravity and cosmic evolution. Over long periods, even entire star systems change, making it difficult to detect signs of past activity. In this way, time acts as a silent gatekeeper. It does not prevent civilizations from existing, but it ensures that their chances of meeting are extraordinarily small. It stretches interactions across such vast intervals that meaningful contact becomes unlikely. The universe, then, is not just a place of immense distances. It is a landscape of fleeting moments. Civilizations may rise and fall like brief sparks in a dark sky, rarely aligning in both space and time. The ultimate speed limit. Why physics prevents contact. Beyond distance and time, there exists a deeper and more unbreakable barrier, one written into the very laws of the universe. This is the cosmic speed limit, the speed of light. According to our current understanding of physics, nothing with mass can travel faster than light. This rule is not simply a technological challenge. It is a fundamental property of reality itself. Light travels at approximately 299,792 kilometers per second. At this speed, it can circle Earth more than 7 times in a single second. Yet even this incredible velocity becomes slow when measured against the scale of the universe. To reach the nearest star, light requires more than 4 years. To cross our galaxy, it would take over 100,000 years. For any civilization hoping to explore or communicate across the stars, this limitation creates an immense challenge. Even if a spacecraft could travel close to the speed of light, the journey would still take years, decades, or far longer. The energy required to accelerate an object to such speeds increases dramatically as it approaches the speed of light, making it increasingly difficult, perhaps impossible, for large-scale travel. This leads to a profound consequence. Interstellar travel is not just hard, but fundamentally constrained. A civilization may develop advanced propulsion systems, but it cannot simply skip across space instantly. Every journey must unfold over time, often far longer than the lifespan of individuals, or even entire societies. Some theoretical ideas, such as wormholes or warp drives, suggest ways to bypass these limits. However, these concepts remain speculative and unproven. They often require conditions or forms of matter that may not exist or may be impossible to create. As far as current science can tell, the speed of light remains an unbreakable boundary. Even communication is bound by this limit. Messages cannot travel faster than light, meaning that every signal is delayed by distance. There is no way to send an instant message across the stars. No matter how advanced a civilization becomes, it cannot escape this delay. There is also a subtle effect known as time dilation. As objects move at speeds close to the speed of light, time for them begins to slow down relative to the outside universe. While this might seem to offer a way to shorten journeys from the traveler's perspective, it does not solve the problem of separation. To the rest of the universe, the journey still takes the same amount of time. In practice, this means that even if a civilization could send explorers to another star system, those explorers might arrive thousands of years after they departed, long after their home civilization has changed or disappeared. Travel becomes a one-way journey into an uncertain future. The speed of light, then, is more than just a number. It is a boundary that shapes the structure of the universe. It ensures that information, matter, and causality all move at a limited pace. And in doing so, it quietly enforces isolation between distant regions of space. In this sense, the universe does not need to forbid contact between civilizations. It simply makes it so slow, so difficult, and so uncertain that meaningful interaction becomes nearly impossible. The expanding universe. Why some civilizations are already forever out of reach. Even if distance, time, and the speed of light were not enough to separate civilizations, the universe introduces an even more profound barrier: its own expansion. Space itself is not static. It is stretching, carrying galaxies away from each other in a quiet, continuous motion that began billions of years ago. This expansion was first observed in the early 20th century, when astronomers discovered that distant galaxies are moving away from us. The farther a galaxy is, the faster it appears to recede. This is not because galaxies are simply flying through space, but because space itself is expanding between them. It is as if the fabric of the universe is slowly being pulled apart. At small scales, such as within galaxies or solar systems, gravity holds matter together. Stars remain bound to galaxies, and planets remain bound to stars. But on the largest scales, beyond clusters of galaxies, expansion dominates. Entire galaxies drift away from each other, increasing the distances between them over time. This leads to a remarkable and somewhat unsettling consequence. There exists a boundary in the universe known as the cosmic horizon. Beyond this horizon, galaxies are receding from us faster than the speed of light, not because they are moving through space that quickly, but because the space between us and them is expanding. As a result, light emitted from those galaxies can never reach us. In practical terms, this means that there are regions of the universe that are permanently inaccessible. No signal we send will ever reach them, and no signal from them will ever arrive here. These regions are not hidden. They are fundamentally disconnected from us by the expansion of space itself. As time goes on, this effect becomes even stronger. The expansion of the universe is accelerating, driven by a mysterious phenomenon often referred to as dark energy. This acceleration ensures that more and more galaxies will cross beyond our cosmic horizon, slipping out of reach forever. For any civilization, this creates a shrinking, observable universe. In the distant future, observers within a galaxy may see only their local group of galaxies, with all others having faded beyond detection. The universe, once filled with countless visible galaxies, will appear increasingly empty. From the perspective of interstellar communication, this expansion adds another layer of isolation. Even if two civilizations exist in different galaxies today, the growing distance between them may eventually make contact impossible. A signal sent too late will simply never arrive. This reveals a quiet but powerful truth. The universe is not only vast, it is actively increasing the separation between its parts. It is as though the cosmos is gently but relentlessly pulling civilizations apart, ensuring that many will never have the chance to know of each other's existence. In this expanding universe, isolation is not just a condition, it is a destiny shaped by the very nature of space and time. Lost in the noise. Why signals disappear in the universe? Even if two civilizations exist at the same time, and even if they attempt to communicate across the vast distances of space, there is another quiet and powerful obstacle. Their signals may simply disappear. At its core, communication depends on the ability to send and receive information. On Earth, this is relatively simple. Signals travel short distances, and even weak transmissions can be detected with the right equipment. But in space, the situation is very different. The universe is not an empty stage. It is filled with background radiation, energy, and noise that can overwhelm even the most carefully sent message. When a signal is transmitted into space, it does not travel as a narrow beam that remains strong over distance. Instead, it spreads outward, becoming weaker and weaker as it expands. This effect follows a fundamental physical principle. The intensity of a signal decreases with the square of the distance. As a result, even a powerful transmission becomes incredibly faint after traveling across interstellar distances. Imagine a civilization sending a signal toward another star system thousands of light years away. By the time that signal arrives, it may be so weak that it is indistinguishable from natural cosmic noise. It may still exist, but detecting it would require extraordinary precision and perhaps a great deal of luck. The universe itself produces a constant background of radiation. One of the most significant sources is the cosmic microwave background, a faint glow left over from the early universe. In addition, stars, galaxies, and various energetic processes emit radiation across a wide range of frequencies. Together, these create a persistent hiss of energy that fills space. For a receiving civilization, this presents a serious challenge. They must not only detect a signal that is extremely weak, but also distinguish it from the natural signals produced by the universe itself. A message could easily be overlooked, mistaken for noise, or filtered out entirely. There is also the problem of direction. Space is vast, and without precise knowledge of where to look, a civilization may never point its instruments in the right direction at the right time. Signals may pass through a region of space unnoticed, like a whisper in a storm. Even if a signal is detected, interpreting it is another challenge entirely. Communication requires a shared framework, some common understanding of patterns, mathematics, or structure. Without this, a message may appear as random data. The meaning, if it exists, could remain hidden. Over time, signals also degrade. Interstellar space is not perfectly empty. It contains particles, magnetic fields, and regions of varying density. These can distort, scatter, or absorb parts of a signal, further reducing its clarity. All of these factors combine to create a quiet but effective barrier. Civilizations may be sending signals across the galaxy, yet those signals fade into the background, lost in the vast and restless energy of the universe. This leads to a subtle and haunting possibility. The universe may not be silent at all. It may be filled with faint whispers of distant civilizations, messages that were sent with intention, but never received. The nature of intelligence. Why civilizations may choose silence. Beyond distance, time, physics, and fading signals, there is one final and deeply human factor that may prevent civilizations from ever meeting: the nature of intelligence itself. When we imagine other civilizations, we often assume they would want to explore, communicate, and connect, just as we do. But this assumption may be limited by our own perspective. Intelligence does not necessarily lead to expansion or communication. It may instead lead to caution, introspection, or even deliberate silence. As civilizations develop, they gain not only technological power but also awareness of potential risks. Broadcasting one's presence into the universe could be seen as dangerous. An unknown civilization might be peaceful, but it might not be. Without any way to predict the intentions of others, a rational strategy could be to remain quiet. This idea is sometimes described as a form of cosmic caution. A civilization may listen carefully to the universe, searching for signs of others, but choose not to respond. It becomes an observer rather than a participant, avoiding unnecessary risk in an uncertain environment. There is also the possibility that advanced civilizations turn inward. As technology progresses, they may create rich internal worlds, virtual environments, simulations, or forms of existence that no longer depend on physical expansion into space. Exploration of the external universe may become less important than exploration of inner realities. Energy efficiency may also play a role. Interstellar communication and travel require enormous resources. A highly advanced civilization might conclude that such efforts are not worth the cost, especially when the probability of success is so low. Instead, it may focus on sustaining itself, optimizing its environment, and preserving its knowledge. Cultural differences add another layer of complexity. Even if two civilizations were capable of contact, their ways of thinking might be so different that communication becomes nearly impossible. What one considers meaningful, the other may not even recognize as a signal. There is also the question of detectability. As technology advances, it may become more subtle and efficient. Early civilizations might produce strong, detectable signals, radio waves, industrial emissions, visible changes to their environment. But more advanced societies could reduce their detectable footprint, becoming quieter over time rather than louder. In this sense, the universe may be filled with civilizations that are not broadcasting, not expanding, and not seeking contact. They may exist in quiet stability, invisible not because they are absent, but because they have chosen a different path. This leads to a profound possibility. The silence we observe may not be a sign of emptiness, but of restraint. The universe may be populated by intelligent beings who, for their own reasons, remain unseen and unheard. And so, the greatest barrier between civilizations may not be physical at all. It may be a shared understanding, arrived at independently, that in a vast and uncertain universe, silence is the safest choice. A universe of islands, our place in the great silence. When we bring together all the forces that shape the universe, distance, time, the speed of light, cosmic expansion, fading signals, and the nature of intelligence itself, a clear and quietly profound picture begins to emerge. The universe is not only vast, it is structured in such a way that separation is the natural state of existence. Each civilization, if it arises, does so within its own small region of space and within its own brief window of time. Around it lies an immense cosmic ocean, where distances are measured in light years, communication is delayed by centuries or millennia, and signals weaken into silence. Even the fabric of space itself works to increase this separation, carrying galaxies farther apart with every passing moment. In this sense, civilizations are like islands scattered across an endless sea. Some may be relatively close in cosmic terms, while others are unimaginably distant. Yet the waters between them are not calm or easily crossed. They are shaped by the fundamental laws of physics, by time, and by the ongoing expansion of the universe. From our perspective on Earth, the night sky appears full, countless stars, faint galaxies, and distant lights stretching across the darkness. But this visual richness hides a deeper truth. Most of what we see is already far away in both space and time. The light from distant galaxies began its journey millions or even billions of years ago. We are not seeing the universe as it is now, but as it once was. This means that even our observations are a form of delayed contact. We see ancient light, but we do not know what exists there today. A civilization that once thrived in a distant galaxy may no longer exist, or it may have changed beyond recognition. The universe reveals its past more easily than its present. There is also a quiet limit to how much we can ever know. Beyond the observable universe lies a vast region that we will never see, no matter how long we observe or how advanced our instruments become. If civilizations exist there, they are permanently beyond our reach, not hidden, but fundamentally inaccessible. Thank you for watching. If you enjoyed this quiet journey through the universe, consider subscribing for more relaxing and fascinating facts. Good night, and see you among the stars.